Hey guys, so I'm going to finish the 3D printed e-bike battery. Well, I'm going to finish one side of it. I started on this side and I haven't done very much here. To get this done, I need to add some additional welds with my welder, and then I need to solder in the copper links. So I'm going to get that done. Now, I always remove my wedding ring because I don't want to be the short circuit. So, sorry if that's boring for you guys, but you know, it doesn't sound like much fun. All right, so we're gonna speed it up here for a second. You know, I wasn't gonna record this piece of it, but well, I thought it was just as interesting as the soldering. So here goes. You know, when I do this, I usually put the prongs down. I push because these are spring-loaded, and then I release, and I don't really apply much pressure. And then when I push, I think when I'm not pushing with too much pressure, there's a little more resistance, and it's the resistance between these two probes that that really creates the heat. So sometimes if you're pushing down really hard and you've got a good strong connection, you'll actually get less heat. Well, you know, maybe I'm wrong about that, but that's what I found at least. So I push down, release a little, keep it on there, and that seems to be how to get the strongest welds. And I think I don't know, I think like four welds, or you know, two tries is probably enough to hold these pretty solid. It's definitely hard to rip them off afterwards. And I've deliberately tested to see and make sure that that's the case. Alright, so I'm going to get through the rest of these. And I'll talk to you again when I'm done. You know what would go well with a high discharge lithium-ion battery? A nice conductive Diet Pepsi can. Well, probably shouldn't put it anywhere around here. I don't know if this is actually conductive. I'm guessing that it probably is, but I'm not looking to find out in this video. All right, back to it. Well, I think that's pretty decent. I've got at least two dual spot welds on each one. Well, I guess two spot welds on each one. And now I'm going to add the copper connections. So what I did for the copper connection, I don't really have a pointer. So this parallel string is passing its current over to this parallel string, so positive to negative, and you'll see that I cut the copper right here and just kind of bended it around like a big C, and that's so that that half the current will go this way and half of it will go this way. That way, instead of just doing like a U, I'm not pushing ever larger amounts of current through a small link at the bottom. Typically, the bike will pull about 26 amps, so there should be about 13 amps running through here. Now, this could probably be a heavier gauge copper, but I think it's going to be okay. Of course, I could be wrong. Guess we'll see. So let me heat up the soldering iron. What I really need is a workshop. But I don't have one. I bought a big reel of copper so that I can easily cut and you know, put it on there. I used to get house wire and just strip it off of there, but that's really annoying to do and it's really messy. So I don't do it anymore. I don't know that this was cheaper, but it's definitely not as annoying. So the good news about this right now is because I don't have any connections on this side, there isn't any risk that I'm going to short this out by accidentally laying a piece of copper across a few things. Once I complete this side and I start working on the other side, I'm going to have to be much more careful, because if I do you know, bridge a few pieces of copper, I'm going to create a pretty wild short circuit. And these cells are rated for 20 amp continuous discharge each. So this thing can pump 100 amps continuously, and you know, if I short this thing out, it's going to be a pretty quick fire and I'll just have to start over again. So speaking of, if you're ever working on batteries, a fire extinguisher is handy to keep around. So I need to work out the length of this copper link, and it's going to be the same for these links here. And I don't want to cut the copper yet, but what I can do is I can use this solder to kind of work out how long it has to be. So there we go, so it's going to be right up to about there. Alright, so that should be, oh boy, the solder's coming up pretty long there. So this should be about the right length. I don't know how long it is, and I'm not measuring it, but this is my template piece. So I'm going to cut the next one the same as. There we go. Oh, which one was the template? Well, I don't know. That's the template. Possibly the new template. So I'll put it here and then bend it over and bend it round and down and over and round again. And turns out that this is a pretty big piece of copper. That was kind of stupid. Oh well, whatever. So now comes the fun bit. So you guys just missed the fun bit because I didn't record it. So I'll go over what I had said. Using a piece of tape, once you've bent that copper link, you can place it down and that'll kind of hold it into place. And then you want to work on soldering the negative connections, and the connections are in between each cell. If you try to solder directly onto the cell will take most of the heat and you won't get a good solder connection. I always start with the negative, because once I've got these solder connections there, the actual piece of copper wire is held pretty solid, and I really don't want the copper wire to move around when I'm trying to solder the positive connection. And the reason for that is because under these paper gaskets is the negative side of that cell, and I don't want to risk shorting it out. This is a little risky as it is, and in the case of a fire, you know, I don't want a fire, basically, is what I'm trying to say. So, unfortunately, you missed me soldering these pieces, but you do get to see me soldering the more dangerous pieces. So, man, that really sucked. All right, so here we go. Now let me show you, see if I can get this in the video. Can you see the gap right there? The gap I'm referring to is here, and I really want that down. So when you're soldering, you want to try to get the copper as close to the nickel strip as possible. And so if you look at these 4 different places where I'm going to be putting solder, try to find the lowest one and start there. And what we'll do is we'll get the solder, and I've got my piece to push down right here. So we're going to push down, drop some solder, and then it's going to start hitting the nickel strip. And then we're going to push down and let go. There we go. Now we have a solid connection. Now you don't want to hold it on there for too long because that is paper. That is a paper gasket under there, and you know, if you burn through it and burn through the plastic wrap on the cell, well, let's just say you're going to find out pretty quick. Alright, so this one looks like it's down pretty good as well. Let's get a solid connection on there. I'm just going to try to push this down a little bit. Yep, there we go. Same thing here. And there you have it. It's a pretty strong connection. It isn't mechanically holding the cells because you have the plastic around there. So that's great. Now I've just got to do a bunch more of them. So yeah, I'm going to fast forward through the rest, but you're welcome to sit here and watch me as I do it. Now that one was was too long last time. And here's how much I cut off. So let's the last thing you want is random pieces of copper flying around while you're trying to solder together a battery. So you'll see I actually burnt the plastic a little bit there. Got to be careful not to do that because it'll probably break down the integrity of this case. So I'm on the last of this type of series connection because I'm linking this positive to this negative, but after that I'm going to link this positive to this negative, and so I'm going to need a different length of copper it won't be one of these C's that I've been making. And because I'm going to have to carry all of the current through the same piece, I'm actually going to double up the copper on that connection. So let's get this one done and then we'll do that one. Alright, so I'm on to this connection, and in case you were wondering, this here is the negative connection of the entire battery, and then over here is the positive connection, and that is why this doesn't actually link to anything, because it would link to whatever the load is. Alright, so let's try this. This is a real pain. You know, I'm kind of guessing a little bit, and maybe that's not such a great thing. But usually I'm pretty close. Hey, that's not bad. It's not bad at all. So what I do want to do here is try to leave enough room for another copper wire to kind of stick to the side, so that there's two, right? So what I'll do is I'll take this one into place right there, push down a little so it doesn't move. I'll try to make sure there's enough space. Hey, that's not bad. All right. Grab an extra piece of tape and put it right here. All right, so I'm going to put a few solder connections on this one. So that one is held in place now. And now I want to add a second one. So again, here goes my approximate measuring. I think this one will be just a tad shorter. There we go. So again, it's just kind of approximate. This time though, I'll put this over the existing solder connection so that I can solder in a new spot. See, there's this one down here. Now really, I should be able to solder both of those at the same time. Hopefully. The important thing is, when you're soldering this much at the same time, is that you want enough thermal mass in the tip, and my tip needs replacing, to be able to do. This is effectively a thicker gauge now. So, all right, well let's just see if it works. There we go. All right. Okay, so I'm basically done with that side. I'm not adding a connection here because there will be an actual 10 gauge wire connected directly to this piece. That's still a little warm. One thing I like about doing it this way is that when you're heating up a cell, the heat dissipates across all of the cells, and so it's not quite as risky. And so here we are now on the other side. And so, just to prove a point, there is voltage in between the cells. So like these ones are connected on the other side. So I'm going to have to be careful to make sure that I link the correct ones together. So I know these are correct because there's no voltage there. Whereas if I put copper between these two on this side, it's going to be bad. Anyway, stay tuned and I will eventually get this side done. Alright, see you guys. One more thing, guys. The most important part of this whole process is putting back on your wedding ring, because when your wife asks you why you're not wearing your wedding ring and you tell her that you were working on something, it's just not going to cut it. She's going to have more questions. Pro tip. See ya.